Ever wondered how wipers work? We will explore another important area, linkage. Let us pin this brown strip in the center. I will place the eraser on the left side. I can lift or lower the eraser by applying force on the right side. This is also called a lever, class 1 lever. Eraser is our load and this point is fulcrum. I will change the position of the pin and this is another type of lever, class 2 lever. Let us spin this red strip just like the brown one but slightly longer. Now we have two levers which can independently function. If we connect these two levers with a blue strip and move the brown strip, what will happen? Moving the brown strip to the right also moves the red strip to the right. Same is true for the other side as well. How about rotating the brown strip? Rotating the brown strip completely oscillates the red strip. This assembly is collectively called linkage. The linkage can be made to change the direction of a force or make two or more things move at the same time. Let us replace red strip with a longer version. Movement of the tip is much wider now. Instead of fixing strips to a box, we will remove strips and join these together with this light blue strip. Pins are bent and pointed end covered with a tape. Now we can achieve the same movement by holding the light blue strip in place. This arrangement is called 4-bar linkage. Blue strip is called a coupler while light blue strip represents a frame. Brown and red strips are side links. These points are called joints. Link that revolves is called crank, while the one that oscillates is called rocker. We can build wiper mechanism using 4-bar linkage. Thin wires are bent and pivoted around the pin. Oscillations are made possible with the help of a wheel. Instead of wires and strips, you can use drinking straws as well to simulate this mechanism. With A4 paper and bunch of sheets as a base, you can try different combinations of linkages. Pins act as a guide for movement of the link. Use this arrangement to build your own visuals.